Assalamualaikum warahmatullahi wabarakatuh. My name is Dayang Noalia Natasha and our group will present about immune system, the ethics of global vaccination. So for the introduction, the human immune system is traditionally viewed as a deeply personal biological shield operating inside an individual body. However, when infectious threats rise to a pandemic scale, this microscopic defense network is subtly transformed into a collective global responsibility. Vaccination scales individual biology into a public safety, creating a mathematical shield known as herd immunity that protects the most vulnerable. Consequently, global immunization is not merely a clinical intervention, it is a profound ethical challenge that forces humanity to balance sovereign national priorities, corporate intellectual property, and universal somatic rights in the pursuit of shared global survival.
Assalamualaikum, my name is Siti Ashabiti Mama Isu and my number metro is 2024670342. What is immune system? Immune system is the body defense system that protects us from harmful pathogens such as bacteria and virus. It works by identifying, destroying foreign substances that can cause disease. The immune system is made up of white blood cells, antibodies, tissue, and organs that work together to protect the body. There are different types of immune system. For example, B cells produce antibodies that help fight pathogen, while T cells destroy infected cells and help coordinate the immune response. Another important component is memory cells. These cells remember previous infection, allowing the body to respond more quickly if the same pathogen enter the body again. Vaccination also helps strengthen the immune system by safely creating immunity against certain diseases. Type of immunity. There are 4 types of immunity. The first is innate immunity. This is the immunity we are born with. It acts as the first line of defense against pathogen and respond quickly, but it is not specific to particular pathogen. Example include the skin, mucus, and some white blood cells. The second is adaptive immunity. This develops after exposure to pathogen. It provides a specific response to a certain antigen and involves B cells and T cells. It also creates memory cells that provide long-term protection. The third is active immunity. This occurs when the body produces its own antibodies after infection or vaccination. Because the body creates its own immune response, the protection usually lasts for a long time. Fourth is passive immunity. This occurs when antibodies are received from another source instead of being produced by the body. For example, a baby receives antibody from its mother. This provides immediate but temporary protection. Function of the immune system. The immune system performs several important functions. First, it protects the body from harmful pathogens such as bacteria, virus, and parasites. Second, it detects and destroys foreign substances that may cause disease. It also helps prevent infection and continuously works to maintain the body health. In addition, the immune system supports recovery after infection or injury by helping the body heal and return to normal function. Role of B cells and T cells. B cells and T cells are very important in adaptive immunity. B cells produce antibodies that specifically recognize and bind to pathogen. These antibodies help neutralize harmful microorganisms and prevent them from causing disease. These cells have a different function. Helper T cells activate and coordinate other immune cells during an infection. Killer T cells directly attack and destroy infect. or damaged cell, blood cells, B cell and T cell work together to protect the body and provide more effective immune system. Importance of antibodies and memory cells. Antibodies are proteins that bind to pathogens and help neutralize them. They prevent bacteria and virus from spreading throughout the body. Memory cells are important because they remember previous infection or vaccination. When same pathogen enter the body again, memory cells allow the immune system to respond much faster and more effectively. As a result, memory cells provide long-term protection and improve the overall effectiveness of the immune system.
What is vaccines? Vaccines is a biological substance that train the immune system. It is contain weakened or inactive pathogens or antigens to help the body produce antibodies and memory cells. It is also provide long-term protection without causing disease. How vaccines work? Vaccines trigger immune response and the body start to produces antibodies and also forms memory cells. It is more faster and stronger response during real infection. This is types of vaccines which are live attenuated, inactivated, mRNA and subunit. What is herd immunity? Herd immunity is when most of the population is immune, and it also reduces spread of disease and also protects unvaccinated individuals. How herd immunity is working? It will break the transmission chain and the disease will slowly or stop spreading. Importance of herd immunity: it can protect infants and elderly.
I am Alia Umaira and I will further continue our presentation regarding ethical issues of vaccine sharing. The global distribution of life-saving medical resources frequently exposes deep structural inequalities between nations. The ethical challenges surrounding global vaccine sharing illustrate a classic tension in bioethics: the impulse of a nation to protect its own citizens versus the moral obligation to alleviate suffering worldwide. The global distribution of vaccines is often characterized by extreme economic disparity, a phenomenon frequently referred to as vaccine apathy. The disparity: high-income nations regularly secure enough doses to vaccinate their entire populations multiple times over, including booster rollouts, before low-income countries can even inoculate their frontline healthcare workers or vulnerable elderly populations. The ethical failure: from a utilitarian perspective, seeking the greatest good for the greatest number of people, this distribution model is highly inefficient. Allocating a vaccine dose to a low-risk individual in a wealthy country yields less overall global health benefit than giving that same dose to a high-risk doctor in a developing country. Vaccine nationalism occurs when a country secures doses for its own domestic market and prioritizes its own citizens ahead of the global population, often using pre-purchase agreements to crowd out poorer buyers. The justification is political leaders argue they have a social contract of fiduciary duty to protect the taxpayer who funded the research and development of the vaccine. The ethical violation is this worldview violates the ethical principle of distributive justice and global equality. It treats human life as inherently more valuable simply based on geographical or political boundaries. Furthermore, keeping vaccines tightly hoarded prolongs the global footprint of an infectious disease, allowing it to mutate into a new variant that can eventually bypass existing immunity, meaning vaccine nationalism is ultimately self-defeating. Wealthier nations possess the financial capital, manufacturing infrastructure, and research ecosystem that drive vaccine discovery. This creates a distinct set of moral obligations, correcting historical legacies. Developed countries often rely on global supply chains and historical wealth accumulation that derive resources from developing regions. Physiologically, they carry a reparative justice obligation to ensure those same regions are not left behind during global crises. Intellectual property frameworks. Wealthy nations face ethical pressure to support mechanisms like patent waivers, for example, TRIPS waivers or technology transfers. Hoarding patents while receiving heavy public funding creates an ethical conflict where corporate profit margins are prioritized over human survival. To achieve fair distribution, global health ethics point away from market-driven models, where the highest bidder wins, and shifts toward need-based models. Ethical distribution frameworks rely on three core principles, which is maximizing benefit and reducing harm, prioritizing individuals at the absolute highest risk of mortality and severe illness, regardless of what country they live in. Next is equal moral worth, ensuring that a person's socio-economic status or geographic location does not dictate their access to essential life-saving healthcare. And lastly, reciprocity, which is shielding and prioritizing healthcare workers, public safety personnel, and supply chain operators who put their lives at risk to keep societies functioning.
What is viral mutation? A viral mutation is a permanent change in the genetic sequence RNA or DNA of a virus that occurs when it makes a copying error while replicating inside a host cell. The viruses reproduce at exceptionally high rates and generally lack the efficient enzymes that human cells use to correct copying mistakes. These genetic typos happen frequently. How viral mutation occurs? First of all, attachment and entry. The virus attaches to a host cell and injected its genetic material, RNA or DNA inside. Second, hijack replication. The host cell's internal machinery is forced to read the viral code and mass-produce new viral components. And the third one, assembly and release. The newly generated, slightly altered genetic strand and packed into fresh viral shells. The cells then burst or release these new copies, some of which you now carry mutation into the body to infect adjacent cells. Effects of any variants increase transmissibility, that mutation occur on the virus surface proteins. Second, immune evasion. Immune system fight viruses by recognizing their specific physical shapes and creating matching antibodies to neutralize them.
Next is the impact on global health and economy. For the global health, it saves millions of lives. Vaccines prevent 3.5 to 5 million deaths every year worldwide from diseases like polio and flu. Global coordination is the only way to wipe out disease completely, just like we did with smallpox in 1918. High vaccination rates create herd immunity, protecting vulnerable people who can get vaccinated, like newborns and cancer patients. It keeping people out of the flu ensures healthcare system don't collapse, living from other emergency. And the last one is impact on global economy. It creates a massive return on investment. For every $1 spent on vaccine in developing nation, society save about $52 in healthcare costs and lost productivity. Vaccine protects global supply chains. A virus outbreak in one country can shut down factories and shipping worldwide. Vaccines keep the global workforce healthy and moving. And the last one is vaccines prevent financial crisis. A prolonged pandemic caused the global economic ruin in lost GDP, spending billions on global vaccine distribution vastly cheaper than fixing a broken economy.
The simple conclusion I can make is vaccines protect individuals while herd immunity is protecting the communities. That's all from me.